This is our last video for lesson 8.9 in AP Calculus curriculum, volume with disk method revolving around the X or Y axis. In this video, we are going to do some examples revolving functions around the Y axis. If we come here, we're going to let R be the region bound by the curve y equals cosine x, the X axis and the Y axis. We're going to find the volume of the solid created or revolving the region R about the Y axis. So let's do like we did before, and let's sketch the curve. Draw. If we have y equals cosine x, we know that curve looks like this. So this is the region we're talking about. And we know that this is at 1. We know that this is at pi over 2. And we're looking to revolve this around the y-axis, so we're going to draw a rectangle like this. Now, again, since this is our x and this is our y, we're going to solve that equation when we're revolving about the y-axis, just like we did when we had the cross sections. So I'm going to solve this for y, and I'm going to take the cosine inverse of both sides and get cosine inverse y equals x. Then I'm going to sketch that graph with y as my independent variable. This is now the y-axis. This is now the x-axis. Recall that that simply flips these axes across the line y equals x, so it reflects it. And this becomes more like this, where this is now 1, and this is now pi over 2, and this is our region, and here's one rectangle that we're going to rotate about the y-axis now. And so we're going to take and draw one of those cross sections with width dy. The radius this time is going to be cosine inverse y. And so the volume of this one cross section is going to be pi times the radius squared. It's going to be cosine inverse y squared times dy. A lot of times on the FRQs, they're going to just ask you to set up an integral, not evaluate it. On the calculator part, we might have to integrate this. But to set up the integral, we're going to go from y equals 0 to y equals 1. Bring the pi outside because it's a constant multiple. And then inside, we're going to have cosine inverse or arc cosine y squared times dy. Now, my calculator application is frozen up on me on the computer, so I can't use it right now until I restart the computer. But I am going to type this in my calculator. Again, remember when we put it in the calculator, we're going to replace these with x's because that's what the TI-84 understands. So I'm going to do in math 9, integral from 0 to 1. I'm going to put in there cosine inverse, second cosine. And that's going to be, I'm going to put the x in there, even though we're really doing a y. And then, I want to make sure I put that cosine inverse in parentheses so that I can square it all. Raise that to the second power. So I'll show you what this looks like in the TI-84. In the TI-84, the calculator, this looks like the integral from 0 to 1. I've got an open set of parentheses that opens with the integral automatically. Then I open a set of parentheses and put in there the cosine inverse. Another parentheses opens. I put the x, close the cosine inverse on the x parentheses, close the cosine inverse so I can square the whole thing. Then it's closed, and then I put dx. That's what it looks like in the calculator in the TI-84. And so when we integrate that with respect to x, or sorry, in this case, respect to y, but in the calculator, it has x. I'm going to enter, and I end up with 1.14159. So I could put 1.141 or 1.142, and that's going to be units cubed because we're doing volume. That's the first example we're going to do, rotate around the y-axis. Let's do another one. This time let's let R be the region bound by the curve y equals x cubed plus 1, the line y equals 6 in the y-axis. We're going to find the volume of solid created by revolving R about the y-axis. Again, I'm going to sketch the graph. Curve y equals x cubed plus 1 is just y equals x cubed shifted up 1. So that happens when y is 1. This is our x-axis. This is our y-axis right now. We're going to the line y equals 6. And we're revolving this about the y-axis. So one of my rectangles is going to look like this. Once again, I'm going to solve this equation for x so I can flip the axes. So I'm going to get y minus 1 equals x cubed. That means that y minus 1 to the 1/3, or the cubed root of my y minus 1, equals x. So I'm going to sketch that graph. Let me put that in black. Where my y-axis is here now, my x-axis is here. And recall again, that simply flips this over the line y equals x. So what we're looking at now, when we do this, the 1/3 y minus 1, we're looking at the curve like this. We're going to the line y equals 6. This is the curve, the cubed root, or y minus 1 to the 1/3 power, or the cubed root of y minus 1. And so now one of the rectangles is here. We rotate it about the y-axis to get a disk. Remember, we're using the disk method. The width of the disk is dy, or the height of the disk is dy. The radius here is y minus 1 to the 1/3. And so if I want to find the volume of that one disk, I'm going to get that volume is equal to pi times the radius squared. Y minus 1 to the 1/3 is y minus 1 to the 2/3 times dy. This intersects the y-axis at 1. So I'm going to integrate from 1 to 6. This is going to be the pi. We can bring constant multiply outside. Have y minus 1 to the 2/3 dy. That would be setting up the integral. We can integrate this one because we can let u, do a little u substitution here, equal y minus 1. Then du equals dy. And so this becomes pi times the integral. Let's see. When y equals 1, u equals 0. And when y equals 6, u equals 5. So we're changing limits of integration to match the variable we're integrating with respect to. And this is going to be u to the 2/3 du. So now we can integrate that. And we add 1 to the exponent. That would be u to the 5/3. And divide by the new exponent. So divide by 5/3 is the same as multiplication by 3/5. We still have our pi outside. And we're going to evaluate that from 0 to 5. So here we have 3 pi over 5 times 5 to the 5/3 minus 0. So our answer then would be 3 pi over 5 times 5 to the 5/3. Now, because we have 5 in the denominator, we can subtract 1, and so that becomes 3 pi times 5 to the 2/3. So that would be our answer. Sorry for the messed up, running out of room on the page thing. So let's double check that one. Look at our calculator, 3 times pi times 5 to the 2/3. Calculator says that's 27.558. So now I'm going to do the integral like we had in the original. I'm going to use x instead of y though. So I'm going to do math 9 for the integrate from 1 to 6 of y minus 1 to the 2/3. I'm putting that in parentheses inside again, because I'm going to use x's and TI-84 instead of y's. I'm going to raise the inside set of parentheses to the 2/3. Then I'm going to integrate with respect to x on the TI-84. And it's calculating. I didn't multiply that by pi, so I'm going to multiply the integral by pi. And that gives me the same answer, 27.558. So we did it correctly. So 3 times 5 to the 2/3 times pi. That would be the volume units cubed for this one. Let's do another fun one. This time, let's let R be the region bound by y equals tangent x, the line y equals 1, and the y-axis. And we're going to find the volume of the solid created by revolving the region about the y-axis. Let's graph again. Y equals tangent x. Where y equals 1. So this is the region we're looking at. I'm going to draw one rectangle. Y equals tangent x. And we know, of course, that this x value, where the tangent is 1, is going to be pi over 4. So now we're going to solve this equation for x. We get tangent inverse x equals, tangent equal inverse y equals x. Solving for x. Then we're going to invert our axes so it makes it a little more clear to us. When we flip that, make this the y-axis and this the x-axis, we get the graph y equals tangent inverse. We're going until y equals 1. We know that's going to occur at x equals pi over 2. We're looking for one rectangle in there revolved around the y-axis. So we're going to draw that over here. Height of the cylinder is dy. The radius this time is tangent inverse y. So now we're going to correct the expression for the volume of one cross section there. And we're going to get pi times the radius squared, which is tangent inverse or arctangent squared, times dy. Then we're going to integrate that from y equals 0 to 1. Put in pi outside because it's constant multiple. Tangent inverse y all squared dy. Again, when I type this in the calculator, I'm going to use the x's because that's the way the calculator understands it, like TI-84. So I'm going to go ahead and integrate that in the calculator. I'm going to do math 9. Math 9, integral from 0 to 1. I'm going to open a new set of parentheses in there because I'm squaring that. I'm going to do second tangent, tangent inverse. We'll put an x there instead of a y. Close that parentheses, close this parentheses, and then square the tangent inverse of x. Then I'm going to, put x instead of square. Then integrate with respect to x. And I don't think I multiplied that by pi. I did not. So I'm going to multiply that by pi. And I get 0.770 or 0.771 because we can round up to 1. But I usually chop just because no room for error there. No way to make an error there if we just chop it at 3 decimals. All right. And that's how you integrate these, revolve these around the x and y axis to get volumes using the disk method.